In this video, you will learn about the surface area of circular three-dimensional figures. So what we mean by circular three-dimensional figures are things like cylinders, cones, and spheres. We're first going to look at cylinders, which is the colored figure here in the first slide. If you look at a cylinder compared to a prism, and here we have a rectangular prism on the left, you can see that they have some similarities and differences. Hopefully some of the first similarities that you think of is that each of them have two bases. The figure on the left has these square or rectangle shaped bases on the top and bottom, and then the one on the right has circles. So that's one of our first differences, is that the bases for a cylinder have circular bases, which is new here. We are used to like triangle bases or hexagon bases, but cylinders have circles instead. The other thing that's similar might be a little harder to tell, but if we were to unfold the cylinder and create a net, this side here in blue would actually unwrap to form one large rectangle with two circular bases on each side. So that's one of the similarities that they have, is that the sides, and remember we call that the lateral area, forms one big rectangle. Now even that similarity has a difference within it, because a cylinder, that is just one side that unfolds to one rectangle. Whereas if we look at the prisms, they would each have separate sides that together make the larger rectangle. So in this one here, they would have four rectangles that together create one large one. So since we're talking about circular bases, we're definitely going to need to use the circumference and area formulas and what we learned during our circles unit. So circumference, remember, is like perimeter for a circle. It is the distance around the circle. And our formulas for that, we actually had two. The first one was pi times diameter. So if you had the diameter instead of the radius, that was a little better. And then the other one, changing diameter into what that would be for radius, would be 2 pi r. So in this circle here that says 12 centimeters as the diameter, we could either do pi times 12, or if we looked at it from the perspective of the radius of 6, we would do 2 times pi times 6. Area, we only had one, and that is just pi r squared. So again, looking here, that 12 we actually couldn't use. We would need to figure out the radius of 6 first and do pi times 6 squared. So definitely keep these in mind as we continue forward. So some of us have been using a formula to calculate the surface area of a prism, and that formula is pH plus 2b, where P stands for the perimeter of your base shape, the H stands for the height of the prism, and that capital B stands for the area of your base. So since cylinders are really like circular prisms, we can take that formula and make some few adjustments to get a new formula for only cylinders. So the first thing we're going to change is P. Instead of perimeter of your base, we kind of need perimeter of a circle, but we call that circumference. So instead of P, I'm going to substitute in the formula for circumference, and I'm going to be using 2 pi r. So again, instead of pH, I'm going to do 2 pi r times the height of my cylinder. Then I'm going to substitute in for capital B. Since I know I'm working with circles every time for a cylinder, the area of that base is going to come from the area of a circle, or pi r squared. So again, substituting in for capital B in my formula, I'm going to instead use pi r squared. So this here would give me surface area of a cylinder. So if you're taking notes while you write this, the first thing you want to make sure to get down is the formula of 2 pi r times h plus 2 pi r squared. And I think it helps to remember that that comes from the prism formula of pH plus 2b. So let's look at a first example. Here we have a cylinder. It says the height of that cylinder is 15. and it gives us the diameter of the base of 20 inches. So be careful, because if you notice in the formula, we want the radius. So if I know the diameter is 20, that means the radius here would be 10. And those are the only two pieces of information that I need in order to find that total surface area. So let's look at the first part here first. I'm going to have 2 times, I'm going to use 3.14 for pi, times my radius of 10, times my height of 15. And remember, that part of the formula gives you the side rectangle of that cylinder. Then my next part would be 2 times 3.14 times that radius of 10 squared. So typing this all into your calculator, this first part here comes to a total of 942. And the second part here for my 2 circular bases comes out to 628. So adding those two pieces together, my total surface area would be 1,570. And remember, units for surface area are units squared. So here for this problem, I would have 1,570 inches squared. The next figure we're going to look at are cones. So here is a side-by-side comparison between a square pyramid and a cone. If we look, there's also some similarities here. They both each have one base, and they both meet at an apex point on the other side of that base. So here we have an apex, here we have an apex. We're going to use these similarities to help us come up with a formula for surface area of cones. Again, some of you have been using a formula to figure out the surface area for pyramids, and that formula was perimeter times the slant height, which is the L you see here, all of that divided by 2, since our sides were triangles and not rectangles, plus only one capital B coming from the fact that there's only one base. Just like we did for cylinders, we're going to tweak a few things to adjust for the fact that we have circles and see what formula we have left. So just like for cylinders, I'm going to substitute perimeter of a circle with my formula for circumference of 2 pi r, and substitute in for the capital B the area of my circle, pi r squared. So subbing these two things in, instead of p times the slant height, I'm going to do 2 pi r. And then instead of capital B, I'm writing in pi r squared. Now if you look, that looks pretty complicated right now, but I see two things that are going to cancel each other out. In this first part, I have a multiplying by 2 on the top and dividing by 2 on the bottom. Those two are going to cancel out, leaving me with my final formula of pi r L plus pi r squared. And that would give you surface area of a cone. Again, if you're taking notes while you write that, definitely write down that formula. Again, I think it helps to kind of see the transition of where that came from with the final here of my pi r L plus pi r squared, where r stands for the radius of that circular base and L stands for the slant height of the cone. If we look at this first picture, I have two different heights going on, which is why it's important to remember that for surface area, we want the slant height, which in this photo would be 17. That 15 is the height of my cone. As you can see, it goes straight from the apex, straight down to the center of that base. And that will be used for volume, not for surface area. So to solve for surface area, I'm going to use a radius of 8 meters and a slant height of 17. So looking at my formula here, again, I'm going to use 3.14 for pi, multiply that by my radius of 8 and my slant height for 17. That would give me my sides of that cone, and add that to the area of that circle base. So 3.14 times 8 squared. This first piece into my calculator gives me a total of 427 4/100ths. And I'm going to add that to the area of my circular base, which here is 296 hundredths. Adding those together, actually gives me a nice final answer of 628. And again, units would be meters squared. Now, spheres are unique. We can't relate them to prisms or pyramids, so their formula is completely on its own. And the surface area for a sphere is 4 times pi times r squared. If you're taking notes, definitely get that formula down. Again, 4 times pi times r squared. And then we'll look at an example together. Here I have a sphere with a radius of 11, and that's the only thing that I need in order to calculate surface area. So I'm going to take 4 times 3.14 for pi times my radius of 11 squared. Typing that into my calculator, I get a final answer of 1,519 and 76 hundredths. Units on that would be inches squared. So the hardest part about these is really knowing which formula to use. So if you can get comfortable with those formulas, the rest is just substituting in those values. So substituting 11 in for where you see r and so forth. After a little practice, I think you'll be great.